This presentation will consist of an energy analysis and recommendation for Wilson Hall and has been created by John Neidhart and Patrick Mateo. Wilson Hall is an integral part of MSU's South Neighborhood. Currently, the building annually consumes about 1,600 megawatt hours of electricity. If the energy requirements of Wilson Hall can be met through alternative energy systems, it could mean a large step towards satisfying MSU's energy transition plan, which strives for the use of 100% renewable sources in the future. The goal of this project was to design two energy production systems that will significantly reduce the power requirements of Wilson Hall. Four main alternative energy systems capable of producing 1,600 megawatt hours of electricity were examined. Ultimately, it was concluded that the solar power and wind power were not economically feasible. Therefore, we decided to pursue and recommend geothermal and biomass systems. To develop the geothermal system, the RET screen analysis software was used. A 5,000 kilowatt Siemens SGO model was selected. Previous projects in Mexico and Iceland were used as references, and a system capable of generating over 1,600 megawatt hours was designed for East Lansing. This system would have a total cost of about $820,000 and a payback period of 7 years. The cost to produce energy would be $37 per megawatt hour. Over a 20-year lifespan, a positive cash flow of $1.1 million could be generated.
For areas like Michigan, biomass can be the key factor because of its high energy density. Over the last few years, biomass systems became smaller and cheaper. The first approach was to substitute the entire consumption of Wilson Hall with a biomass power plant, but considering the local conditions and the current price level, the big power plant would not be profitable. In contrast to that, we also analyzed the small-scale power generators. All Power Labs produces the PowerCube PC20, providing electrical power of 18 kilowatt at 60 Hz. This system requires 1.15 kilogram of biomass per kilowatt hour of electrical power. Based on a price of $13 per ton for wood pellets, this means a saving potential of 69%. With the PC20 CHP version of this power generator, one can use additionally nearly 15 kilowatt of heat output. The system operates independently. It is imaginable to build a biomass plant with a stack of these systems. The advantage of these stacked systems would be that it is possible to switch on and off each power cube separately within a few minutes in order to deliver only the power needed on demand. This would reduce and optimize the biomass consumption. If we intend to build up a power cube farm with a capacity of 400 kilowatt, one needs 23 power cubes. The following calculations show the dimensions of the applied system. The figure shows the theoretical cumulative cash flow. One power cube costs around $45,000. This kind of system is more applicable for a dome like Wilson Hall and more profitable after 20 years. Due to East Lansing's location and climate, geothermal and biomass systems are the best short-term solutions and could be implemented in a step-by-step manner. Smaller-scale biomass systems are very attractive because they are protected from fluctuating prices of petrochemical products, and the university wouldn't have to invest in a 20 to 30 years project. The implementation of these systems would be an important step for MSU to meet the requirements of its energy transition plan.